Hello friend, welcome to my YouTube channel Mechanical Design Adda. In this video, we will discuss the injection molding process in question and answer format. Okay, so we will explore the complete injection molding process so that it will help you in the interview or it will enhance your knowledge about the injection molding. Okay, so let's start the video. Our first question is, what is plastic injection molding and what are the primary applications of the plastic injection molding? Okay, it is a manufacturing process for the plastic component. Okay, so it is widely used to produce the plastic part. Okay, so we have here the mold. Okay, so one side it is a cavity, on other side it is a core. Okay, this side is a core and this side is a cavity. Okay, and this is the injection unit where we are with the help of screw we are pressurizing the material and injecting into the mold. Okay, and in the injection means in the mold unit there are two hubs. Okay, one is a cavity and another is a core. Okay, and in the middle you can say this is the product. Okay, after with the help of ejector pin we are ejecting the means part from the mold. Okay, so the injection molding, this process is widely used to produce the plastic part. Okay, so it is used in the industry like automotive, consumer goods and electronics, medical devices and more. So the injection molding, so the product of the injection molding, so you can find in all industries. Okay, like housing, gears, there are plastic gears are there, knobs are there, and the packaging of the different product. Okay, so we are surrounded with a number of plastic components. So most of the components are produced by the injection molding process. Okay, so there are other plastic manufacturing plastic part manufacturing process are there, like blow molding, rotational molding, compression moldings are there, and the injection molding is also there. So the injection molding is a most commonly used process for the manufacturing the plastic part. The next question we have, can you explain the main component of injection molding machine? So in the diagram here you can see that the injection molding machine, it is divided into 4 section. Okay, one is a injection unit section, it completely injection unit section is there. Another is the mold section, or you can next one is the clamping section, and another is the control section. Okay, so there are 4 main sections are there. So injection units, clamping units, mold unit, and the control systems. Okay, so the injection system here you can see we are melting the material and injecting the plastic material into the mold. Okay, and here on the clamping unit, so the clamping unit hold the 2 molds together, so firmly hold the 2 mold. Okay, and the control systems is used to manage the entire process, like cooling units, opening and closing. Okay, and injecting the material, like all those things are controlled by the control system. The next question is, what factor influence the selection of plastic material for the injection molding? So this question is related with the material selection for the injection molding. So the choice of the plastic material for the injection molding, it depends on the intended use of the part. Okay, so where we are using the part, so in which condition we are using the part, under the high stresses, under the normal stresses, under the which environment condition. So all these factor we will consider in this use of the part. Okay, and another is the material requirements, like material having the mechanical and the thermal property requirements that we will see in the material. Okay, that also we will check the mechanical and thermal property in the material. Also the cost plays a very important role. Okay, so cost consideration also plays a very important role, and the regularity requirements like approval from the governments and the environmental impacts of that material on the in the pollution. Okay, that also plays a very important role while selecting the material for the injection molding. So in general for the injection molding we are using polyethylene, polypropylene, ABS material, polycarbonate material, and the nylon material. So these are the general material we are we are using for the injection molding method, okay, or the process. Next question is, what are the primary stages in the injection molding process? So the injection molding process involves the clamping, injection, cooling, ejection, and the close of mold closing. Means this is the sequence. Actually first we will clamp the mold. Okay, so to mold we will clamp and we will close the complete mold so that it will form the complete cavity. Okay, so the first step is to clamp the mold. Okay, then we will inject the material into the mold. Okay, so this stage is injection stage, and then we will allow the plastic material to solidify and solidify from liquid stage to the solid stage. Okay, so here in the cooling stage we will allow the plastic to solidify. Then ejection. So with the help of ejector pin, so we will remove the part from the mold. Generally, so after the cooling, the part will stick to the mold surface. So we need the ejection pin. So this step is ejection. Okay, is to remove the part from the mold. Okay, and last stage is mold closing. So after removing the part, we will close the mold for the next cycle, and after that the same process, the process will repeat, like clamping, injection, cooling, ejection, and the mold close for the next part. Okay, so this is the sequence for the injection molding process. The next question is, how is the cooling stage managed in the injection molding? Okay, so the cooling stage is a very important stage in the injection molding process. Okay, so here in the graph or in the circle you can see that, so this shows the 35 seconds of cycle time for the injection molding. So out of this one you can see here, for the cooling more than 50% time is taken by the cooling process, and rest all are the half. Okay, so here you can see mold close, filling of the material, pack and holding of the material, and then cooling allows the material to cool and open and eject the part. So out of this one, the cooling stage takes the more than 50% of the cycle time. Okay, and here you can see the cooling. So related with the cooling, so cooling is managed through the strategically placed cooling channel within the mold. Here you can see this red one is the part, and it is surrounded with the cooling channel. So the cooling channel are there. So in the mold we are passing the liquid. Okay, so we are passing the liquid, it will be the water or the different oil coolings also there. So we are creating the cavity inside the mold, and we are passing the liquid inside the mold, so that we can rapidly cool the part, and we can reduce the cycle time. So because here you can see that most of the cycle time is consumed by the cooling only. Okay, more than 50%. Okay, so this channel facilitates the rapid and the even cooling of the mold. Okay, even cooling of the plastic, and it will help to solidify the part efficiently and reduces the cycle time. Okay, the next question is, what are the common defects that can occur during the plastic injection molding? So there are number of defects are there, but the most common defect in the plastic injection moldings are it means shrink mark will occur, wrapping and flash, and the short. Okay, so the shrink mark. Okay, so in the picture you can see one depression or the shrink mark. Generally we call it as a shrink mark, but it is a depression in the plastic part. Okay, here you can see. So it is due to the uneven cooling. Okay, and this shrink mark will occur again. And another is the warping. So warping is the defect where the shape of the part, you can see here, it is changed. Okay, so it is nothing but the deformation of the part. So it is generally caused due to the non-uniform cooling or the internal stresses in the part. Okay, so and another is the flash. So flash, it is generally means most of the time this will occur because of the proper if the proper closing of the mold is not there, then at that time this flashes will be occur, because in the mold gap the material will flow. Okay, so we to avoid this flash, we need to tightly bolt on the mold. Okay, so we need to tightly bolt the mold so that this flash we can avoid. Okay, and another is a short. So this is the defect where the material is not reach at the end. Okay, so it is nothing but the incomplete filling of the mold cavity. So this type of defect will occur in the injection molding. So the next question is, how do you optimize the injection molding process for consistent quality? Okay, so to have the consistent quality in the injection molding process, we need to focus on the injection pressure and the temperature. So this one is a very important parameter for the injection molding process, like a pressure and the temperature. So the most of the defect we can avoid by maintaining the proper pressure and the temperature for the injection molding process. So this one is a very important. Then we need to focus on the cooling time. Okay, so and also we need to focus on the mold design and the part design also. Okay, so there are some guidelines that we need to follow before we are designing the mold and the part for the injection molding process. Okay, and also material selection also plays a very important role for the quality of the part. Okay, and the regular maintenance of the machine and the mold is also very important. Okay, so so for the consistent quality in the injection molding process, so these are all the parameters that we need to take under the consideration to have the good quality product. Okay, and so in this graph you can see that the cycle time. Okay, so the cavity pressure you can see here on the y-axis, or on the x you can see the time. Okay, in second. So here we can see that the 35 seconds cycle time is there to produce the one part, and out of that you can see the cooling. So the cooling is occupying more than 50%. Okay, so here the closing is there. First portion is closing, then we are filling the material here, and after that we are allowing the material for the cooling. Okay, to solidify, and this one is the ejection process. So here you can see the pressure is going while filling. So the pressure is going at that, and we are holding here. Okay, so this pressure we are holding here, and after that we are releasing that pressure to zero, means closing. means opening of the mold here, we ejecting at that time opening. Okay, so this graph is related with the cycle time and the pressure. Okay, what are the advantage and the disadvantage or the limitation of the plastic injection molding? So the advantage here we can see with the plastic injection molding. So with the injection molding we can produce the complex part. Okay, so means thin ribbing and the complex geometry we can produce with the help of injection molding. Okay, and here we can get the high repeatability, means this process is quick and within a second we can produce the part. Okay, and here we we will get the less material waste. Okay, so here we are means wasting of the material is very less. Okay, so first one is the complex part we can produce with the help of injection molding, and also high repeatability is also possible, and minimum waste is there. Okay, and limitation of this process is so high initial cost we need to pay for this injection molding process. Okay, so the limitation on a certain material property. Okay, this is one limitation, and here we need a skilled person to operate the machine and maintain the equipment. Okay, next question is, how do you troubleshoot issue that arise during the injection molding process? So suppose there is an issue or the defects in the injection molding, so how we can troubleshoot? So we can troubleshoot with the help of root cause analysis. So that troubleshooting involves the identifying the root cause of defects, so our issue. Okay, and after that we will adjusting relevant process parameter. So we will perform the root cause analysis, so why that defect is coming. Okay, so after that we will study all those inputs and we will take the corrective action. Okay, so here we can take the example, if the part has shrink mark, at that time they adjusting the cooling time. Okay, adjusting the cooling time or the temperature could help to address the problem of the shrink mark. So most of the time in the injection molding process, so if you play with the pressure and temperature correctly, then you can avoid the most of the defect in the injection molding process. The next question is, can you explain the concept of a gate in the injection molding? So the gate is nothing but it is a point at which the molten plastic enter into the mold cavity. Okay, so here you can see, so it is the connection between the cavity and the runner. Okay, so from the runner the molten plastic is coming, and with the help of gate it is entering into the cavity. So here you can see the narrow section is there, so here pressure will increase and it goes into the required shape of the part. It is a cavity here. Okay, and here in this image you can see the multi cavity mold is there, and here these are all are the gates. Okay, these all are the gates, and this one is a one common sprue, and these all are the runners. Okay, this means sections are the runners, and these all are the gates for the cavity. So this is a multi cavity mold. Okay, and here you can see the different types of the gate we are using in the injection molding. Okay, so it is means the gate, it is typically a small opening that is strategically placed to ensure the proper filling of the mold while minimizing the visual marks on the final part. So the gate is nothing but the small opening that is placed to ensure the proper filling of the mold while minimizing the visual marks on the final part. Okay, so it will minimize the visual marks on the final part. Okay, it is a small opening. Okay, so the gate location and the design influence the factors such as part appearance, strength, and the cycle time. Next question is, what are the key parameters that affect the quality of final injection molded part? So the quality is is very important for any part. Okay, so the key parameters that affect the quality of the final injection molded parts are like melting temperature of the material, injection speed of the material, injection pressure, mold temperature, cooling time, and the holding pressure. So these are the all parameters that plays very important role in the for the product quality. Okay, so these factors collectively impact the part dimension, surface finish, strength, and the overall quality. So this all factor plays a very important role in the injection molded part. Next question is, how does the choice of mold material impact the injection molding process? So this question is related with the mold material. Okay, so the mold material must have the good thermal conductivity to facilitate the efficient cooling. So as we in the last question we discussed that the most of the cycle time it is consumed by the only cooling cycle. Okay, so the cooling cycle takes more than 50% time it is taken by the cooling stage in the cycle time. Okay, so our mold must have the good thermal conductivity so that it can release the heat from the mold. Okay, so the common material generally we use for the mold are steel and the aluminum. Okay, so these two material we will use for the injection mold. Okay, so generally the steel mold offers the durability and the precision for high volume production. Okay, at that time we will use the steel mold, and the aluminum mold are lighter and suitable for prototyping and the low volume run. Okay, what is the difference between hot runner and cold runner system in the injection molding? So the primary task of any injection runner system is to direct the material flow from screw to the mold cavity. Okay, so and the system requires the additional pressure to push the material through the runner. Okay, so the primary function of the injection runner system is to direct the material flow from the screw to the mold cavity. Okay, so here from screw to the mold cavity the material is flowing, okay, through the runner system. Okay, so there are two ways. Okay, one is the hot runner system and another is the cold runner system. So the hot runner system heat the mold and runner. Okay, heat the mold and runner channel to keep the material in the molten stage for the duration of injection process until it flows into the mold cavity, leaving no plastic inside the runner. Means, so here you can see the hot runner process. So here you can see this hot runner system is keeps the mold and the runner both in the hot condition. Okay, in the hot condition it will keep, and here after the ejection of the final part, so here you can see that there is no plastic inside the runner. So because of that there is no wastage of the plastic here. Okay, and in the cold runner system, okay, so the runner and the mold are not heated, and so the plastic fills the runner. So here you can see the plastic fills the runner. Here the plastic is filled with the runner and also with the cavity. Okay, so and leaving the runner part to connect it until they ejected separately. Okay, so after the ejection also you can see this filled runner, you can see here with the screw. and with the part we need to cut out. Okay, so we need, after the ejection we need to cut this extra material, so it is comes under the cold runner system. Next question is, how do you prevent the defect like warping in the injection molding part? So how we can prevent the warping defect in the injection molding? Okay, so to avoid the warping, so we need to optimize the mold and the part design. So we need to follow the certain guidelines that for the part design or the mold design. Okay, so and also we need to ensure the uniform cooling of the part or the mold. Okay, and also we need to manage the stresses inside the part. Okay, also we need to properly place the gate, okay, into the mold. Okay, and we need to use the rib structure for the structural component. Okay, so we need to use the ribbing for the part, and also we need to control the cooling rate so that it will help in the minimizing the warping. Okay, so here you can see that what is the warping. Okay, so this one is the design part, and after the manufacturing of the part you can see that there is an deformation, okay, or there is an bending type, okay, bending of this wall. Okay, so this is called as the warping defects. Okay, so the warping in the injection molding is actually the deviation or the deformation, you can see. It is caused due to unintentional bending or the twisting of the plastic part at the end of the injection molding process. So after the injection molding process, so if this part is bended or the deform this complete surface, then this defect is a warping defect. And how we can avoid this warping defect? We can we need to follow the design guidelines like mold guidelines. We need to keep the uniform cooling, and also we need to manage the stresses and gate system. We need to properly we need to place the gate, and we need to use the rib for the structural part so that it will not deform. Okay, and also controlling the cooling rate also it can help to minimize the warping. Okay, the next question is, what is the significant draft angle in the injection molding? So the draft angle is nothing but the taper. We are tapering the wall of the part. Okay, so the vertical wall of the part we are giving some angles so that we can easily remove the part from the mold. Okay, so here you can see that with the straight one it will stick with the mold surface, but when we apply the taper it so that we can easily remove the part from the mold. Okay, so draft angle prevents the part from getting stuck with the mold. So with the help of draft angle we are preventing the part getting stuck with the mold. Okay, so generally if you see, we need to give the more draft angle to the part so that we can easily eject from the mold. So the draft angle of 1.5 to 2 degree is required for the most of the part. Okay, but it depends on the height of the wall. Suppose the height is very small of 1 to 3 mm, then we need to apply the more draft. Okay, more than 3 degree. Okay, and if the height of the wall is suppose 50 mm, 100 mm, then at that time we need to apply the less draft, less angle, almost 1 degree, 1.5 degree, 0.5 degree, like that. Okay, so here you can see the 0.5 degree on the all vertical faces. It is strongly advised. So don't keep the wall with the no draft angle. Okay, so always give the 0.5 degree instead of there is no draft. Okay, so 1 to 2 degree work very well in the most situation. Okay, and 3 degree is minimum for shut off. Okay, shut off is where the metal and metal sliding is there or in the mold. Okay, so and 3 to 5 degree is required for the texture. Okay, so these are the some means guidelines for the draft. Thank you friend, thank you for watching this video. So this one is a part 1. I will upload the part 2 as well. So thank you for watching. If you're not yet subscribe the channel, please subscribe the channel and hit the bell icon so that you will get the updated videos from Mechanical Design Adda. Thank you for watching.